after transformation, the new value is vi dash. Okay. We solved this problem. We transformed this income, $73,600 to a range 0.0 to 1.0. So this is the new minimum and new maximum. So we have transformed this value to 0.716. Okay, using this min-max normalization. Here in this algorithm, in this technique of normalization, you need to know the new boundaries, new range should be known, new minimum and new maximum should be known. Then only you can perform this. And one more technique is Z-score normalization. This is also called as a zero mean normalization. Why it is called as zero mean is, once all the attribute values are normalized to new values, if you perform the mean will be zero. After transformation using this approach, if you find out the mean of all the new values, it will be zero and the standard deviation will be 1. The standard deviation will be 1. The new mean will be 0 and new standard deviation will be 1. Okay, so this is the formula. We'll subtract input from we'll subtract the mean from the input and divide the standard deviation. So you're transforming vi to vi dash. So you have to find this mean as well as standard deviation. Only if these two values are known, you can perform this. If not given, they'll be giving you the list of attribute values. Anyway, if you want to perform the data analysis, the attribute and its values will be there. So you need to find out its mean and standard deviation. Then only you can apply this Z-score normalization. And the third approach is a decimal scaling. Yes, so this is a simple technique where we divide the given input by 10 powers. And the index to be chosen, that is 10 power j. The j value that is to be chosen depends upon this criteria. And I have explained you this criteria, right? The simple technique is, if you want to transform this range, you consider this range 986 to 917. So you can divide with the total number of digits, 10 power total number of digits. So this is 3, right? So 986, 917, 3 digits. So 10 power, you can consider 10 power 3. So if you divide it with 10 power 3, we'll be getting minus 0.986 and this one is 0.917. So this is normalization by decimal scaling. So till now, till here we discussed. And the next data transformation technique is a discretization. So discretization means you are transforming continuous values to a discrete form. So mostly the attribute values will be in a continuous form. Continuous data will be there. So it can be transformed to discrete form. Discrete form means it will be having, countable number of values. Countable number of values will be there. So these continuous values can be mapped to certain intervals or labels. Simply, numerical data can be transformed to some categorical data. It can be either intervals or labels, concept labels. A simple example is age. If you consider age, it is having a multiple values. Okay, so they all these age values can be grouped into some intervals, or even you can assign some labels for that. 20 to 39 one group, one interval, 40 to 59 one interval, 60 to 79 one interval, and even you can name them as a youth. This 20 to 39 can be youth, or 40 to 59 can be adult, 60 to 79 can be senior. In this way, we'll discretize this age into interval labels or some conceptual labels. So we have different discretization techniques. One is binning. So we know about this binning technique. This is even used in smoothing the data. And also in case of numerosity reduction also, we applied this binning technique. And even here in data transformation also, binning can be used. So for discretization by binning, the input data set need not have the class labels. So you know about the class labels, right? So if a particular entity is assigned to one category and assigned a label, then we call it as a class label of that record. For example, frequently purchased customers, moderate customers, infrequently purchased customers. So labels. Okay, grade A student, grade B student, grade C student, grade D student, labeling. So labeling the student entities. Okay, and if you consider employee data, maybe labeled as assistant professor, labeled as associate professor, class labeled as a professor. So class labels, if class labels information is not used for discretization, then it is unsupervised technique. So here this binning is unsupervised. It will not use the class information. Okay. This is the example that we have discussed in the last class. Given the bin interval, will discretize the data. Here you can see, yeah. So this is this column. This column indicates all the possible values of an attribute in all the rows. So how many rows are there here? 4 plus 6, 10 plus 10, 20, 33, 42. 42 data values are there. Let us consider this is an attribute for 42 rows. We're considering this attribute. We want to discretize this data. Let's consider, for example, age. So you are discretizing this. Okay, so using this binning technique, I'm giving the input as interval. So number of bin interval size 4. So 1 to 5 will be the first interval, 6 to 10 will be the second interval, 10 to 15, 16 to 20, 21 to 25. So every interval size is 4. Yeah, so if you consider 1 to 5 values, so including 1, excluding 5, 1, 2, 3, 4, these values of the attribute will fall into the first interval. So it's having how many data points? 4 data points. And second interval have 6 data points. Third interval has 7 data points. You can count them. So this is the count of the number of data points present in these interval. Similarly, 16 to 20, we have 13 data points. 21 to 25, we have 9 data points. So in this way, we can divide the data into intervals using this binning. And one more technique is discretization by histogram analysis. So this is also an unsupervised technique which do not use the class label information. So this histogram technique will partition the values of an attribute into disjoint ranges, where each range is said to be a bucket or bin. This histogram technique we have discussed in data reduction. Okay, the same technique can also be used in the data transformation. Means your we have two ways of histogram constructing the histogram. One is using equal width and another one is equal frequency. Okay, equal width means the interval size will be fixed, whereas equal frequency means will try to make the intervals in such a way that the number of data points in each interval are almost same. So that is equal frequency histogram. Okay. And one more technique is discretization by cluster analysis. We know clustering is a technique for grouping the related data. Grouping the related data. Based on the features of the data, we can group the data. So this is the clustering. So clustering also will not use the class label information. If you don't have any class label information also, we can do this clustering. Clustering, grouping of data can be done without the class label information. So it's an unsupervised technique. Okay, so this clustering algorithm can be applied to discretize the numerical attribute by partitioning the values of that attribute into clusters or groups. So our main intention is to convert this continuous data into discrete data. For that, you can apply binning, histogram, or even clustering. So this clustering can be done in two ways: a top-down approach and bottom-up approach. So if you consider the top-down approach, it means that yeah, all the data points will be considered as one cluster. Initially, all the data points will belong to the same cluster. According to this top-down approach, all the data points will belong to the same cluster. And at every step, we'll divide this cluster into multiple groups. At every step, each cluster will be decomposed into subclusters. Okay. For example, if you consider some 1,000 data points, so these 1,000 entities or data points or records, these 1,000 entities initially will be in the one cluster. Later, based on the features, similarity of the features, we'll try to divide this 1,000 into, for example, two clusters. Let us consider as two clusters. So number of clusters can be given as input. So two clusters. So maybe some 400 entities in one cluster and 600 entities in one more cluster. Now these two clusters again in the next iteration can be further divided into two more clusters. Okay, so this is the procedure of top-down splitting. And coming to bottom-up merging, so this top-down technique is called the splitting strategy, whereas bottom-up strategy is the merging strategy. So here, every data point is considered as a single cluster. Considering the same example, if 1,000 entities are there, initially we assume that we have 1,000 clusters. And at every step, we'll try to merge the similar clusters. We'll try to merge the similar clusters. This will be repeated. At every iteration, we'll try to merge the similar clusters. So initially, more number of clusters will be there because every entity is treated as a cluster. Later on, we'll try to merge them. Okay. This is bottom-up merging as we follow this merge sort technique. It's a bottom-up approach, right? The same way here, bottom-up merging strategy. So clustering can be done in two ways. So here, yeah, we'll try to create or generate the concept hierarchy. In case of discretization, we'll try to create a concept hierarchy. Concept hierarchy, after creating the concept hierarchy, so we can replace the low-level concepts with higher-level concepts. For example, if you consider a location dimension, so location dimension will have different levels of attributes, means order of the attributes. For example, location dimension has an attributes called street, city, state, country. Country will be the highest level concept, whereas street is the lowest level concept. The concept with more number of values will be the lower level concept. The concept with less number of values will be higher level concept. Yes, that's obvious, right? The street values will be very large compared to country values. The number of possible values for the country will be less compared to possible values for the street. Okay, so in that way. Similarly, if you consider time dimension, so time dimension also have a concept hierarchy. So it can be day, next week, next month, next quarter, next year, like that. So day is lower level, year is higher level, like that. Okay. Yeah. And next one is discretization by decision tree analysis. So decision tree is a classification technique. Here, we can use this decision tree technique for discretization purpose. Okay, it can be used in data transformation. So what is done in this classification technique is, we use the class label information for creating a classification model. Unless you have this class label information, model can't be built. But that's not the case with the clustering. Without having the label information based on the attribute features, we'll group the data. But in case of classification, we'll consider each label of the entity, each label of that particular row or record, and then we'll build the model. Okay, a classification model can be built. So here, actually, we call this a supervised technique, as decision tree construction involves knowing the class label information. We call it as supervised technique. So already in the previous class, I mean, in first unit, I've given you an idea of supervised and unsupervised learning, right? Supervised, unsupervised, semi-supervised, active learning. So all these we have discussed. So decision tree approach, it makes use of the class label information, and hence we call it as supervised technique, and it is also a top-down splitting strategy. Because why we call this as top-down splitting approach is, initially all the data will be in the root node of the tree. Root node, decision tree, we are building the tree. Tree means which have the root, interior nodes, and finally the leaf nodes, branches also. Okay, so how to construct this decision tree based on the given data, that we'll discuss in our third unit, where decision tree classification algorithms are applied. Okay, yeah, given some set of data, we'll first select one attribute as the root attribute, and at the root attribute, all the complete list of entities, or all the complete list of data set will exist. So later we'll perform a test on the root, and then we'll have the branches. The outcome of the test will represent the branch, and at every branch we'll select one more attribute as the interior node. Okay, so this process is repeated until all the records are assigned to one of the leaf. So what is the leaf is class label. Class label is the leaf. So at present, you can't understand this decision tree. I'll explain you with example in your third unit. So what you have to know here is, even classification and clustering techniques can be used to perform the discretization technique. What do you mean by discretization? You're transforming the data which is continuous into discrete form. Okay, continuous data will be transformed to discrete form. So as this decision tree uses the class label information, we consider this technique as supervised discretization technique. And one more discretization technique is discretization by correlation analysis. So we have heard this correlation analysis in, what is that concept? Finding out the redundant attributes. Yes. If you want to find out the correlation between the two attributes, there will perform the correlation analysis. We have discussed that topic. We have found correlation between two numerical attributes, and also correlation between non-numerical attributes as well. Okay, so there we have learned the chi-square test. The same technique is applied here, this chi-square based discretization, and we call this as chi-merge. Chi-merge is chi-square based discretization technique. Okay, so this is a bottom-up approach. It means that each entity will be considered as a separate interval. A separate interval, as we follow in a bottom-up merge technique. Okay, so every entity will be considered as a separate interval, and then at excuse me, in the later iterations, we'll try to merge the neighboring intervals. Best. Any doubt? Yeah. So we'll try to find out the best neighboring intervals and merge them to form large intervals. Okay. So Yeah, this child merge will make use of the class label information, and hence we call it as a supervised technique. So how this child merge is performed is, initially every distinct value of an attribute A, you are performing discretization for this numerical attribute A. Let's consider you are discretizing a numerical attribute A. Now, every distinct value of A is considered to be one interval. And now we'll perform this chi-square test for every pair of adjacent intervals. So we know how to find out this chi-square test, right? So chi-square test requires construction of a contingency table. Am I right? We have already done that example. That is age and preferred reading. Not age, it's gender. Gender and preferred reading. We consider these two attributes, and then we constructed the contingency table where we'll find out the what is that, actual count and observed count. I mean, actual frequency, observed frequency. These two are used to find out the chi-square value between these two attributes. And if this chi-square value based on the, this is a statistical test actually. So based on the degree of freedom and the hypothesis that we consider, will finally conclude whether to reject the hypothesis or accept the hypothesis. So you can please revise that concept where we discuss this chi-square test. The same concept is used here. We'll find out the chi-square between two adjacent intervals, and the intervals whose chi-square value is very less, those intervals will be merged, because the lower chi-square value indicates that these are the intervals with the similar class distributions, means these are similar. So the two intervals with the lower chi-square value will be merged. So this process will be repeated. It's an iterative approach. Or you can even use the recursion technique for performing this processes. Okay, so chi-merge is a chi-square based statistical technique which is used for discretization. So initially, every unique value of the attribute will be considered as a separate interval, and at every iteration, we'll find out the chi-square value of adjacent intervals, and then try to merge the intervals whose chi-square value is less. This is repeated. Okay. Yeah. So it is about this data pre-processing. So in this data pre-processing, we have discussed data cleaning, next data reduction, and then this data transformation, which involves these normalization techniques. Okay, so now I would like to explain this data pre-processing with an example. So I'll consider a simple data set, and then we'll discuss how this missing data will be handled, how the data transformation and normalization is performed. Okay, so here I have used R programming language. So R is a statistical programming language. So even you can use Python for data pre-processing. As I'm familiar with R compared to Python, I have used this R. Let me share that PPT. Okay, is the screen visible? The new PPT. I hope it's visible. So, yeah, thank you. So data pre-processing in R. So this is very a simple language to learn, and even to install these R programming language, I have given you the links here. So we need two exe files. So I have included those two links. One is R and another one is RStudio. So RStudio is actually the GUI. it's a graphical user interface. So where you can perform execution of the programs. Okay, so you can go to these two links and then download and install R. It's very simple process to install this. Okay, it's not that much complex. You can easily install. Actually, this is not in your syllabus. R is not included in your syllabus of data and web mining. But in order to explain this pre-processing technique with an example, I have included this. Yeah. For performing pre-processing, first we need data, right? So we need to import the data. So first you have to download the data, and then you need to import that data into your R environment. So how the data will be created? I mean, how you will obtain the data? So you have two ways. One is you can download the data set from the existing resources. Okay, we have UCI machine learning repository where you can find the data sets for data mining, machine learning, or data science. For all these models, we have the predefined data sets in UCI machine learning repository. Okay, and one more is you can download the data sets from Kaggle.com. Kaggle also provides many data sets for this data science applications. So this is one method, just downloading the existing data sets. The second one is based on your application, you can create your own data set. So what do you mean by data set? A list of features and list of records, right? Rows and columns, which forms a data set. Okay, so you can create your own data set based on your application. That is another way. Creating the data set is one, and already using the existing data set, that is another approach. Okay, yeah, after getting the data, you need to import the data into your IDE. IDE means here RStudio IDE, Integrated Development Environment. Okay, in this, yeah, I will show you the RStudio once. After completing this discussion, I'll show you this RStudio also. So in order to import the data set, we use the statement read.csv. So read.csv is a function in R programming language to import the data into your environment. So here the left-hand side of this assignment is a variable. It's a variable data set. I have named it as data set. It's a user-defined name. You can give any name. Okay. Yeah, read.csv. CSV means comma separated value. Most of the data will be in CSV. So it will be in an Excel file, as I have shown here. You can see this. So this is I have collected from the Excel sheet. Okay. Yeah. So here in this read.csv, you have to give the complete path of this file. I mean, current directory. You need to give the source path, data.csv. This is the file name. And if it is present in some other directory, you need to mention the complete path. Okay. I mean, if your present working directory is different from directory where this file is present, you need to mention the complete path within the quotation marks. So this is a very simple data set with 4 columns: country, age, salary, purchased, and 10 observations. I mean, 10 rows. Okay, this data set will show how customers from 3 different countries, France, Spain, and Germany, from 3 different countries with different ages and salaries, respond to the purchase of a product. Their responses regarding purchase of a product, whether they purchase that product or not, yes or no, their age, their salary, and their country. Yeah. In order to view the data in our environment, we use the function view. This is name of the data set. I have named it as data set only. Same name is used here. This R is a case sensitive programming language. So there is a clear difference between lowercase and uppercase. So here V is the capital letter. And the user defined variable name, it can be either lowercase or uppercase. It can be any combination of both. As I have used this capital D here, at everywhere where you access this particular data set, you need to use the same capital D only. Otherwise, it will not recognize, it will give an error as it is case sensitive. Okay, if you see this data set, here you can find some missed values. Missing values. So in this record, you can find NA. NA means not available. It's a missing data. Okay, in case of salary information also, at Germany, here you can find missing data. So, okay, first let me discuss how to handle this missing data. We have learned many techniques, right? Can anyone name few of them in chat box? I guess we have seen some 6 techniques in handling missing data. Anyone? Yeah, filling by constant value, filling by mean, ignoring the tuple. That is one technique. Using the regression technique for finding the most probable value. Many techniques are there. Yes, manual entry, which is a time-consuming approach. Yeah, finding out the median and then replacing the value. That's correct. So different techniques are there. So here I have used mean. So age and salary are the numerical data where the data is missing. Okay. Yeah, everyone answered it correct. Now we need to ensure the missing data is eliminated. So instead of removing the rows, means instead of ignoring the tuple can be done in case of large data. But here we have only 10 records, right? So instead of removing the rows or ignoring that particular tuple, I'll calculate the mean and then replace that missing value with the mean. So replacing the missing data in the age column with the mean of that column. So this is the statement used. So you can find here data set $age. So data set is the name given to that particular data set. I have named it as data set only. That's why data set. Okay, this is the name actually, use defined name, which can be named in any way. $age. This dollar symbol is used to access a particular attribute in that data set. We have 4 attributes, right? To access age attribute, I'll give dataset name $age. If to access country, I'll give dataset name $country, like that. Okay. Yeah. So I'm using an if-else statement. Here, try to understand this. is.na. This is the first parameter of this if-else statement. is.na returns either true or false. So it checks whether this age value in this particular record is NA or not. So all the values are not NA, right? Only one among all the 10 values is NA, not available. So it will check for each record, and then only if it is true, means if it is not available, then this second parameter will be evaluated. The second parameter. If is.na returns false, means not available is false, means the data exists, then this third parameter will be available. I hope you know the conditional operator syntax that you have learned in your C language, conditional operator. Okay, so the same thing, if else. So if this is.na returns true, the second parameter will be evaluated. If is.na is false, the third parameter will be evaluated. Here, the second parameter is the syntax of finding out the average of this age column, and then will replace this data set $age with that mean value. Okay, so here we use average function, and here we call this mean function. Actually, mean and average are similar. They perform the same task. So mean is it finds the average or mean of all the values and returns a single value. That is mean. It returns only a single value. Whereas average, it finds out the average of all the values and replaces each one with the mean. Multiple values. Average returns the multiple values. Of course, here we need the multiple values for age, but only this is dot na, which is true, must be replaced. Okay, this mean function that we used here, yeah, here you can see this parameter na.rm equal to true. This indicates that will not consider, or we will remove the na values while calculating the mean. That is the meaning of this na.rm equal to true. While performing the mean, we'll remove the na values. If na.rm equal to false, it indicates that we are considering na also for calculating this mean. So if that is the case, the result of the mean will also be na. Result of mean is also na. If na.rm is equal to false, then na will also be considered in the mean calculation, which finally returns na. So, but that's not our, that's not the case that we want here. We want to eliminate or remove that na and calculate the mean and replace only that na with the mean. Okay, so this is actually the syntax of R. Yeah. Next one is, see, after executing that statement, you can see here this Spain. Previously it was NA, now it is 38.77778. This is average of all the values present in this age column. As we perform this average, all the values will be in float instead of integer. They are in float, but our age will be in integer. Mostly we'll consider age as integer. We can round it up using round function. So round off this age attribute present in this data set. 0 indicates 0 decimal places after decimal point. 0 places after decimal point. Okay, the same is overwritten in data set $age. After executing this statement, the age will be in this way. It's rounded. See here, you can see this 38.777. This is rounded to 39. Okay, now the same can be applied to salary. The same can be applied to salary. The same statement we have applied to salary, and I think this one, this salary value at Germany, so this is replaced by the mean value. Okay. Yeah. And now I want to perform data transformation. So what kind of transformation is, I'm converting the text data to numeric data. Text data to numeric data. I want to apply it on country. So because many machine learning models, actually they work on the numerical data. If that is the case, you can transform the text data. You can map the text data into equivalent numerical values. So we know country have 3 values here in our data set: France, Spain, and Germany. Okay, so these 3 values are mapped to 1, 2, 3. These are the new labels assigned to these country attribute values. France will be mapped to 1, Spain will be mapped to 2, Germany will be mapped to 3. For that, in R, we use factor function. This factor function is used to transform the text data to numerical data. So you're applying this factor for this column data set $country. The levels parameter indicates what are the possible values for this country. Here C is a combined function which is used to represent a vector. So here France, Spain and Germany will represent a vector. So see, this C function is a combined function in our programming language to create a vector. For creating a vector, we use that function C. Yeah, so here France, Spain and Germany, these are the three levels of a country. Okay, so these levels will be mapped to three conceptual labels. Three labels. I'm giving three labels here. 1, 2, 3. After executing this statement, your data set will be in this way. So France will be replaced by 1, Spain will be replaced by 2, Germany will be replaced by 3. So this is done for all the records in the database. And similarly, I can do this for purchased attribute also. In purchased attribute, we have no yes. So I want to assign the labels 0, 1. Okay. So for that, the same syntax as we used in the previous slide for country, the same syntax is applied here. The factor function is used. Okay. We have the levels, no and yes. Levels parameter indicates the possible values in that attribute. Labels indicates what are the labels that you want to assign it to those possible values. So no will be mapped to 0, yes will be mapped to 1. But if I execute this statement, at the place of 0, we got NA, not available, which indicates the label NA. I want to replace it with 0. For that, I executed the second statement. So the second statement is dot NA, means if the data set $purchase, if this attribute value is NA, then I'm replacing it with 0. NA value will be replaced with 0. Okay, yeah. So these 0 and 1 are actually considered as the numerical data. No S or text or categorical data, and then I'm converting it to numerical data. If you want 0 and 1 to be categorical, then we can use this function as dot factor. This as dot factor will treat 0 and 1 as two categories. It will treat 0 and 1 as two categories. For that, we can execute this third statement. Okay. Yeah. And now we have learned this normalization technique, right? We can apply this normalization so that data will fall within the same small range. So we know age and salary are having a continuous values, right? So these are continuous values. Now you want to discretize it or you want to normalize it. Okay, for that here I applied zero score, I mean a zero mean Z-score normalization technique. What is Z-score normalization technique? From the input VI minus mean divided by standard deviation. So that is done in R using the function scale. This scale function is used to perform the Z-score normalization on a group of numerical attributes. We can apply this to multiple attributes at the same time. So I want to apply this scale function to attributes age and salary. So what is, in R, every column will be numbered. The first column is country, right? It is number 1, age is numbered as 2, salary is numbered as 3, purchased is numbered as 4. So I want to apply this scaling technique, normalization technique, all the rows, but for only second column, third column. Even you can apply from 2 to 3, 2 to 4, 2 to 5, 2 to 6, like that. So, based upon your requirement, here I need to perform only for second attribute to third attribute. You can do for second to fourth, like that. So I want to apply only for age and salary. So I used 2:3. 2:3. It can be X is to Y. X will be less than Y. That's the criteria. X is to Y. X less than or equal to Y. So you can see here an empty space or empty between, this indicates, this is a subset operation. This square bracket indicates a subset operation. Data set, subset, row, comma, columns. Row, comma, columns. Columns I need only 2:3, 2 to 3. Rows, I want to perform for all the rows. So we can leave it as empty. If I want to perform only for first row to fifth row, then we'll give 1:5, comma, 2:3. But here I want to perform the scaling for all the rows. So simply you leave that row field and just you mention comma 2:3. So this syntax will normalize the second and third columns using Z-score normalization. Okay. Let me execute these in our R. Can you see the screen? I hope this RStudio is visible to you.
Yes, ma'am.
Yes, thank you. Yeah, so this is an RStudio environment where we can execute our R code. Here, the actual IDE is divided into four parts. So this upper corner, upper left, upper right, lower left, lower right. Wait a second. Yeah, upper left, upper right, lower left, lower right. Okay. Yeah. This is the console. This one is the console where you can execute one command at a time. I mean, one statement. It's not command, one statement. One statement at a time can be executed. Okay, so this R programming is mainly used for statistical purposes, statistical programming language. Okay, so for executing one statement at a time, we use this console. So we can type here. For executing multiple commands at a time, we use this upper left corner here, this one. I'll show you now. So this one, this area is used for two purposes actually. One is to view the data set. We can use this. We can see here, you can see the data set, right? So I've performed this, all these steps. So this is the resultant data set actually. I'll show you from step 1. Okay, so you can view the data set, and one more is it acts as the place where you can give multiple statements and execute. All the statements can be executed at a time. I mean, like a script, we can write all the statements and then we can give them here. We'll be having a run command, run this one, run. Okay, after clicking run, all the statements will be executed. Okay, yeah, and this this is a history tab where it will show all the commands which were executed previously. Here we have one flexibility. If you want to repeat the execution of the previous commands, you can select them and then even you can move it to console or you can move it to source. You can move it to console, to source, even you can save that. Okay, so that is the purpose of this window. And now, and the last one here we have a window where you have multiple options. You can see here files, plots, packages, help, viewer. So yeah, mainly plots. As I said, this is a statistical programming language. It's also useful for graphical programming. Means, I mean, for plotting the graphs, we can use this R programming language for plotting the graphs based on the result of the data sets. We can use this, and also packages. So it has many built-in packages. We call them as system libraries. You can, and also multiple user libraries. We can, if any library is not there, you can click on install, give the package name as input. I mean, you can have to type the package name and then install. Then automatically it will be installed. Okay. Yeah, let's execute our example. Yeah, already I have executed it. I'll just show it for you. In history, I have these. I'm moving it to source. Yeah. So you can see here, move it to source. Okay, I'll rename it dataset 2. I'll consider as dataset 2. Okay. Yeah. So we'll run this. Dataset 2 is create. Let me see what is present in this dataset. For seeing views, view of dataset 2. So this is the dataset. You can find missing values at this 7th row as well as 5th row. Okay. So yeah. For handling that, we use this if else statement. This one. Okay. Let me run this. Okay, let me check this. Sorry, it's a data set 2, right? So I think previously also I applied for data set. Yeah, let me repeat it. Data set 2. Data set 2, right? Data set 2. If you want to execute specific statements, you just select them and then click run. Otherwise, all the statements will be executed. Even you can type here. Sorry, what happened? Oh. Already we have, right? I'll select this. Data set 2. Okay, so average age is found and then it is replaced here. And A is replaced by 38.7778. Yeah, we'll apply this round. It's data set 2. Data set 2. Execute this. Data set 2. I'm executing this statement. Okay, it's rounded. Age attribute is rounded. So you perform the same for salary. All these commands already I have executed, so they are present in history. I'm just selecting them and moving it to source. It's this one. But the dataset name is changed, right? Dataset 2. Okay, let's view the. Okay, salary field, salary column is also, missing value is replaced here in salary column also. Okay, yeah. Later what we did, I think we have transformed the data, right? This one. I am labeling France to 1, Spain to 2, Germany to 3. See, any label can be used. That's the user choice. Let me change the dataset name. Yeah. Yes, it's transformed, right? The text data is transformed to numerical. Okay. Data set 2. Yes, it's done. See, now if you see this, so here we are transforming this no and yes to 0 and 1, right? But if you see, all the 0 is replaced by NA. So we'll convert all these NA values to 0. Okay, so NAs are replaced by 0. Yeah, that's the thing. And next, yeah, performing this normalization. So scaling the data means you are scaling the data to lower range. Okay, so this is the result after scaling. So this is Z-score normalization. You can check it. The mean of these values will be 0. Standard deviation will be 1. Same for salary odds. Okay. So these are the steps we performed on this data set. We performed this data cleaning by handling this missing data, and then we transformed the text data to numerical data, and then we normalized the numerical values of age and salary. Okay, so depending upon the application, data pre-processing steps may vary. Okay, that depends on your application. Yeah, any doubts, students? If you have any queries, you may ask regarding this data pre-processing. Because I'll give you an assignment for this week, which will be counted for mid-exams. Already we are conducting daily quiz. So that will be considered, as well as your assignment marks will be considered for the mid-one evaluation. So I'll give you pre-processing technique. I'll share you the document. There you can find all the details of the assignment. This is on a data pre-processing only. You can do it using Python. If you're familiar with Python, you can do it with Python. In Python also we can do it. Even you can use the Java programming language and code it in all these, but the number of lines will be more in Java. So for data cleaning and all these things, the code will be more. But in case of Python and R, it's simple. Yeah, you received the mail, right, regarding offline classes from next Monday. From next Monday, you have offline. Yeah. We shall meet on next Wednesday in the campus. Electives are running online. Now, all the core courses also on online only, right? Not only electives, but core courses also online only. But from Monday, everything will be online. Sorry, offline. So yeah, I didn't understood your question actually. Few electives are running online means everything is online right now. From 14th, only few electives will be online. Who said? Who said this information?
Ma'am, few like in other electives, few seniors are there. They are not coming to the campus.
Seniors means you have 4th years, right?
Yes, ma'am.
I think for 4th years, it's not mandatory. For first and second year, hybrid mode. But for 3rd years, they've kept it as a mandatory.
Yes, ma'am. But for few electives, there are seniors in that, so They may run online.
In case of electives, so your fourth years are also okay. Fourth year students are also doing the same course.
Yes, ma'am.
Okay, but ours is not the same, right? I mean,
Yes, ma'am.
yeah, we have only third year students. Yeah. Yes, do you have any queries regarding this data pre-processing? I hope you understood this data pre-processing. Okay. Let me start another topic. Frequent pattern mining. Yeah, let me share that. So this is your next topic in second unit, frequent pattern mining. So yeah, already in the first unit, I have given you some introduction related to pattern, frequent pattern, association rule. While discussing this data mining functionalities, I have given you the introduction. Let me repeat that. Okay, so a pattern can be set of items or a subsequence or substructures. Okay, so these patterns might occur in a data set. If they occur frequently, if these some set of items or a sequence or a substructure occurs frequently in a data set, then we call it as a frequent pattern. Okay, so depending upon the data set, these may vary. If you consider transactional data set, so we have the patterns as item sets and sequences. If you consider the graph data, then you'll be getting substructures within the graph data. So depending on the data set, these patterns may vary. Okay, so whatever the pattern which occurs frequently in a data set, we call it as a frequent pattern. Actually, this concept is initiated by Agrawal and his team when they started research on frequent item set mining and association rule mining. These two are related actually, frequent item set mining and association rule mining. You know, association rule will be of the form X implies Y, where X indicates some set of items and Y indicates some set of items. Purchase of X leads to purchase of Y. Purchase of item set X leads to purchase of item set Y. So that is association rules. In order to generate these kind of rules, I mean, these kind of associations between the multiple items, we need to find out the frequent item sets first. We need to find out the frequent item sets, then only rules can be generated. Okay, so this frequent item set mining and in general way we call it as frequent pattern mining, but specifically in your syllabus you have frequent item set mining. Frequent item set mining is one part of frequent pattern mining, because you can see set of items, sequences, structures, etc. We are dealing with this first one, set of items, which we call it as frequent item set mining. Actually, this is the first problem that is solved in frequent pattern mining. Later on, it is extended to subsequence mining and substructure mining. Okay, so don't get confused with frequent item set mining, frequent pattern mining. Frequent item set mining is a part of frequent pattern mining. Okay, so in general, we call it as frequent pattern mining. Specifically, we deal with frequent item set mining in our second unit. Okay. So these frequent pattern mining is applied to market basket data analysis, cross marketing, designing the catalogs, sales campaign analysis, weblog analysis, DNA sequence analysis. So in all these applications, we use frequent pattern mining. Okay, the motivation of this frequent pattern mining is finding out the built-in regularities, means inherent regularities that occur within the data. We need to find out these regularities present in the data. For example, simple one. What products purchased together frequently? Next, what are the subsequent purchases after buying a specific item? Here, PC refers to personal computer. After purchasing this personal computer, what are the possible arrival of the customer again to the shop for some other items? What are those items? So what are the subsequent purchases after buying this PC? Finding out all these. Okay, what kinds of DNA are sensitive to specific drugs? If a new drug is invented, what kinds of DNA are sensitive to this new drug? Okay, so can we automatically classify the web documents? So this is done based on the weblog analysis. So all these questions can be answered with the help of this frequent pattern mining. Okay. Yeah, this frequent pattern mining is applicable in many other data mining functionalities. We have many data mining functionalities. One is frequent pattern mining or association rule mining. And next one is clustering, classification, outlier analysis. So all these, there are many data mining functionalities. So in many of these tasks, frequent pattern mining is used. So yeah, in association and correlation analysis, we use this, and finding out the sequential patterns, subgraph or substructures. And it can be applied to spatiotemporal data, which consists of the space information and time information. It can be applied on multimedia data. Okay. So time series data and continuous data that is being streamed, stream data. On stream data also we can apply. And in classification analysis also, this frequent pattern mining is used for performing classification. We have many classification techniques. So one among them is frequent pattern mining. I mean, using this concept also, we can classify the data set, how we can do it. So that is a classification analysis. Similarly, this frequent pattern mining is also used in clustering. It's also used in clustering. So actually, initially for each of these data mining functionalities, some standard algorithms exist. Okay, for example, in case of classification, we have decision tree classification technique. So that is the foremost one. I mean, that is the initial one developed for classification. Later, many of the techniques arrived. Okay, so yeah, in every technique, some problem will be identified and that will be rectified with the new approach. And similarly, clustering. Initially, k-means clustering was developed. K means clustering. So the problem in that technique will be identified and then some new other techniques are invented. So this process is a never-ending process. Building the new algorithms is never-ending process. Okay, so for this clustering, there is a technique called frequent pattern based clustering, which makes use of this pattern mining concept, frequent pattern mining concept. So what I want to say here is this is foundation for many other data mining tasks also. So because data mining evolved from the base, that base is frequent item set mining. The base of this entire data mining is frequent item set mining. Okay. Yeah. So basic concepts in frequent pattern mining. So you can see the database here. This is a sample database. I'll describe the terminology here. Item set. Item set refers to group of one or more items. Okay, group of one or more items. K item set indicates item set with K items. Item set with K items. You can see here X1 so on up to Xk. K number of items present in this item set, which is called K item set. Okay. So all these are the basic concepts which are used for knowing the frequent item set mining algorithms. In order to know those techniques, we need to know these terminology. And support. We have two supports. One is absolute support and another one is relative support. Support. Support of whom? Support of an item set. Support of an item set. It's nothing but frequency. Frequency of an item set is said to be support count or absolute support of an item set X. Here you can see the database. Can you say the frequency of beer in this data set? Means in how many transactions that item occurred. So what is the frequency of beer here? Can anyone answer? Yes, that's correct. That's correct. It is 3. Okay. So its absolute support or support count is 3. Similarly, what is the frequency of nuts? It is also 3. It occurred in transaction ID 10, 40, 50. Okay. So what is the absolute support of difer? 1, 2, 3, 4. Right? That is called absolute support or support count. Frequency of the item set. So here I am saying item set, but asking for only individual item. An individual item is also called as an item set. I am defining it as one or more. If it is one, we call it as one item set. If the item set has 2 items, we call it as 2 item set. If it has 3 items, we call it as 3 item set. If it has having K items, we call it as K item set. Okay. Yeah, even we can have an item set with single item. That's what the question I asked. Frequency of beer, frequency of nuts, frequency of difer. Okay, now I will ask you a simple question. What is the absolute support of beer, comma, difer? Can anyone answer? Beer, comma, difer. In how many transactions it occurred? 3. Right. Funny, you're correct. It occurred in TID 10, TID 20, TID 30. Means both of them occurred together. In how many transactions both of them occurred together? So beer, comma, difer occurred in TID 10, TID 20, TID 30. So its absolute support is 3. That is the meaning of absolute support. Now, okay. Yeah, let's go for relative support. Relative support is fraction of transactions that contain the item set. Means the probability that a transaction contains the item set. This you can find by dividing the absolute support by total number of transactions. Okay, absolute support by total number of transactions will give you the relative support. So what is the relative support of beer here? T divided by 5. Total number of transactions is 5. So 3 divided by 5 is the relative support. Okay, understood? Is it clear? Don't get confused with absolute support and relative support. Okay, so relative support is probability. Yeah, and now we have to know when we call an item set as frequent. That is based on a threshold value, which is called minimum support threshold. Here you can see MINSUP, which is minimum support threshold, which will be defined by the user. Okay, I mean, before running this frequent item set mining algorithm, which generates all the list of frequent item sets, we need to give it as input. What is that? Minimum support threshold. For example, If I consider minimum support as 3, then we can say beer as frequent because its frequency is 3, greater than or equal to minimum support threshold. Okay, if I consider minimum support as 4, is beer frequent here? It's not frequent because its frequency is only 3, but my minimum support threshold is 4. It's not satisfying the minimum support threshold. So item set beer is not frequent. Okay. So when we say an item set as frequent is if its support, if nothing is mentioned, then we consider it as absolute support. Simply support is given, right? You can consider it as absolute support. If X support is no less than a minimum support threshold, then only we call it as frequent. Okay. So yeah, a simple question. My minimum support threshold is 3. Now the question is milk frequent item set or not? Answer it. Is milk frequent item set or not? Yeah, Likita, you're correct. It's not frequent. Manish, yeah, correct. Yeah, Dayal, correct. Okay, because its frequency is only 2. It occurred in transaction 40, transaction 50. Yeah, yes, Manish, it's 2. So it's less than 2 is less than the minimum support threshold 3, so it's not frequent. Okay, so here you can see, yeah. So customers who buy beer. So this represents, this Venn diagram, this represents number of customers who buy one item. And the second indicates this one, this diagram. So this indicates number of customers who buy diaper. So there exists some customers who buy both, right? Okay, who buy both. Customers who buy this item only beer, only diaper, both. This common area represents intersection of these two. Okay, both beer and diaper. So you may get doubt why this item beer is included in this data set, because actually, so all these are some grocery items, right? Coffee, diaper, eggs, milk. But why these beer item was included? Actually, there was a story regarding this beer and diaper. You can go to Google and search for it. So beer diaper story. It's also called as beer diaper syndrome. That is, in Walmart. Walmart is it's a mart where multiple items were purchased, located in USA, I guess. Yeah, Walmart. So they found one correlation between this beer and diaper. They found out that the purchasal of beer and diaper together is more at Friday nights. So this is the correlation they found. Purchase of beer and diaper at Friday nights. And the reason they found out is, so this is actually purchased by the young men who married and then have kids recently. Okay, so those men actually Friday nights maybe they go for purchasing beer. So I mean that is a place where all the items are present. All the items can be purchased. So yeah, so they went for purchasing beer, and at the same time they were asked by their wives to get the diapers for their kids. That is the one reason, and vice versa also. Actually, they go for Friday, they go for diapers to the shop, and they might see these beer in the shop. As it is Friday night, and as it is a weekend, they might want to purchase this beer also. Both the situations are possible. So this correlation is found by this Walmart people. I mean, Walmart company. So they found out the purchaser of these two items. Actually, these two are not correlated, right? So there is no relation between these two items. Eggs and milk, okay. Milk and bread and butter, So they have correlation. But what about the correlation between Beer and Diaper? Yeah, they found out this. Okay. So actually, many people say this is a story. This is not actual thing. Many people say this is a story created. To show that two unrelated items also have the possibility of correlation, and this can be found by mining the frequent item sets from the database. By mining the frequent item sets from the database, this kind of correlations can be found. Okay, so that is this Beer-Diaper story. Yeah. Now I would like to connect a quiz in this basic concepts. So I hope you understood this frequency, right? The question is based on this frequency only. If you know this, then you can easily answer. Yeah, you have only 3 questions. I'll give you 5 minutes of time for this. So I hope you understood this minimum support threshold. That will be given as input. And if the frequency or support of an item set exceeds or same as this minimum support threshold, greater than or equal to, if